It is given that two non-mixing liquids of densities rho and n rho, where n is greater than 1, are putting in a container. So we can consider that there is a container over here, and inside container we are considering two different liquids, not a single liquid, two different liquids, immiscible liquids, and they are having different densities. So the one with a density rho and another one with a density n into rho. So the liquid with the density n into rho is going to sink, and the density rho is going to float because the value of n is greater than 1. So we can say that one liquid is over here and another liquid is over here. Are put in a container. The height of each liquid is h. So if you are taking it as this height is equal to nothing but h, then this height is also equal to nothing but h. A solid cylinder of length L and density D is put in this container. Now we are keeping a solid cylinder inside this. So assume that we are having a solid cylinder, something like this. It's kept inside the liquid of the length is given as L and density D. So density of this container is given as nothing but D. The cylinder float with its axis vertical and length P into L, where P is less than 1, is in the denser liquid. So some amount of this one is in a denser liquid, so we can just take it as this distance is given as nothing but P into L. So the remaining distance over here, which we can take it as nothing but L minus P into L, or we can take it as L into 1 minus P, that is L minus L into P, which is on the liquid which is having less density, because the total length of this container is given as nothing but L. If the in the denser liquid, the density D is equal to, so our aim is to find out the value of density in terms of rho. So in this situation, we can say that both the liquids are going to exert upthrust on this one. So like liquid over here is going to, some part of this one is in liquid having density rho, and the remaining portion in the second liquid. So we can say that the net uplift or upward force or buoyant force will be equal to force exerted by both the liquids, or upthrust exerted by both the liquid. Now the upthrust exerted by the first liquid is nothing but volume of first liquid. Let's say first volume of object in the first liquid, take it as V1, and density of liquid rho into acceleration due to gravity. Like that we can write upthrust exerted by second one is volume of object in second liquid into density of liquid, which is nothing but n times of rho into acceleration due to gravity, and which is going to balance the weight of this object. Let's say that is equal to mg. So we can write the value of V1 into rho into g plus the value of V2 into rho into g should balance the value of weight of this object mg. Now we can write the value of V1. V1 we can take it as area of cylinder into length in the first liquid, which is equal to L into 1 minus P into density of liquid rho into, if you want, you can cancel this acceleration due to gravity g. So this is plus volume in second situation, which we can take it as our volume of liquid in the volume of object in second liquid, that is area into length is nothing but P into L into density of liquid, which we can take it as nothing but N into rho, is equal to the value of mg. Weight we can take it as, or mass we can take it as density, that is density of object D into volume, which we can take it as area into length. So we can cancel this L and A, this L and A, and this L and A. So remaining thing we can take it as nothing but rho into 1 minus P plus rho into N into P is equal to nothing but density D over here. So if you are taking this density as common, it is 1 minus P plus N into P is equal to nothing but D. Or you can write the value of this density D is equal to rho into, we can take it as 1, and if you want you can take this P as common, so it is going to be 1 plus N minus 1 into P is equal to the value of D.